Okay, students, so today we'll be studying ratio, rate, time, and speed. This is chapter 9 from your mathematics book, and it is the first lecture for the month of March. Let's continue. Just few things before we start off. The more you practice this chapter, the more you get a hang of it. There are some very basic and small formulas, very small calculations, and try not using the calculator at times, but if the values are big and if you cannot test yourself, then go ahead with the calculator, but try it with your mental maths first, then proceed. And do practice it a lot. This is an easy chapter. The more you practice, the more you get a hang of it, and the more you can control it during your final term exam. So let's begin. Okay, what are ratios? A ratio is used to compare two quantities of the same kind, which is measured in the same unit. For example, two distances are compared. For example, 10 kilometers and 20 kilometers are compared. These are same quantities, as you know, both are distances and they have the same unit, kilometers. Okay. For example, the ratio of x is to y, where x and y are two quantities of the same kind, is written as x ratio y. For example, we use how do we mention ratios when it is clearly mentioned in the example x is to y. That means x will be the first term of the ratio and y will be the second one. We use colon to represent ratios. Since ratios are a means to compare two quantities, we can also express it as a fraction, because fraction is also used to compare the numerator and the denominator. You can see on the right hand side how the fraction is expressed. Okay, moving on. Equivalent ratios. What are equivalent ratios? Equivalent ratios are two ratios that express the same relationship between numbers. We can create equivalent ratios by multiplying or dividing both the numerator and the denominator of a given ratio by the same number. That means, for example, 2/7 is the equivalent ratio of 4/14. How come? Because both the numerator and the denominator are multiplied by the same number. When it is multiplied by the same number to give a certain fraction or a certain ratio, that means the ratio by which the number is multiplied and the new outcome are equivalent ratios. You can see 8/24 when divided by 4 gives you 2/6. You divide both the numerator and denominator. Since the numerator, both the quantities are divided by the same number, we can say that 8/24 is the equivalent ratio to 2/6. Moving on. Okay, simplifying ratios. This means reducing ratios into a simplest form. For example, simplest, or we already know what simplification is. We used to simplify numbers when it was in fraction. For example, 2/4 was a simplification for that. We use 2 and we use 4. So how will we simplify that? We'll check which factor is the common between both of them. You can clearly see 2 is common, so 2 ones are 2 and 2 twos are 4. So the simpler form is 1/2 or 1/2. Okay, expressing ratios as fractions, you already know that fractions are also used to compare two quantities. So we can either write ratios or we can either write it as a fraction. Moving on. Okay, here's a question to get you guys up to speed. In a bag of red and green sweets, the ratio of red sweets to green sweets is 3/4. If the bag contains 120 green sweets, how many red sweets are there? So we know the ratio of red and green, but we don't know the amount. We only know the amount of sweets. green sweets. We don't know the amount of red sweets. How will we do it? We'll assign variables first. What are variables? We know we did chapter 4 algebra. Variables are used to define an unknown quantity. So since red sweets are unknown, we assign x to red sweets. We'll write it as fraction since we're comparing the green sweets to the red sweets. We're comparing the red sweets to the green sweets. We write 3 ratio 4 as fraction, 3 upon 4, and we can write x, which is unknown number of red sweets, upon 120, which is the known number of green sweets. What will we do after this? We'll just solve for x. We'll just solve for x. We'll cross multiply. We'll multiply 4 by x and we'll multiply 3 by 120. You can clearly see the answer. 3 into 120 is 360 and 4 into x is 4x. Since we want to know the value of the variable, we separate the variable. Isolate means to separate the variable. After we separate the variable, it gives us, since it's multiplying over here, 4 is multiplying with the variable. If we move it to the other side, it will divide. Whenever something is multiplying on one side, we divide it on the other side. If something is adding on one side, we divide on the other side. Whenever one thing is adding on one side, we subtract it on the other side. Whenever one thing is subtracting on one side, we add it on the other side. Same goes for multiplication and division. So we divide 360 by 4, we get 90. 90 is x. Since moving back to the first step, we assign x to red sweets. So the value of x is 90. So the number of red sweets are 90. I hope that's clear. If this was an easy one, just practice and keep your head in the game. How will you keep your head in the game? You will concentrate on the keywords that are given in the word problem. Moving on. Okay. Clothing store A sells t-shirts in only 3 colors: red, blue, and green. So here we have three quantities of ratio that are being compared. So here we go. The colors in the ratio of 3 to 4 to 5. If the store has 20 blue t-shirts, how many t-shirts does it have altogether? Okay, since we have two number of unknown t-shirts, what we'll do, we'll assign variables to both. We only have the number of blue shirts, so we'll assign x to red shirts and we'll assign y to green shirts. Why will we do this? Because both of the values are unknown. Remember, we're assigning variables. That means that the values are unknown. You can clearly see. Now to write it as a fraction. When we compare, why are we comparing red to blue and green to blue? Because from the question we know that the amount of blue shirts is 20 and the ratio of blue shirts is also given. We are comparing a known quantity to an unknown quantity. You can clearly see red to blue and blue to green. Okay, so 3 upon 4 and x upon 20. 3 is the ratio of red. We don't know the number of red shirts, so we write x. 4 is the ratio of blue shirts, and 20 is the number of blue shirts. Same goes for green. What we'll do, we'll basically cross multiply the same way we did the last question. We get both values of x and y after cross multiplying. Once we get the answers of x and y, we have to find the total shirts. So we know the number of blue shirts in the question. We know what are the number of red shirts. The number of red shirts was x, which is 15. The number of green shirts were y, which are 25. So when we add all of these, we get 60. The total number of shirts are 60. Moving on. Okay, so moving on to the next topic of this chapter, rate. What is rate? Rate is also a comparison of two related quantities, but they are in different units. Related quantities here exactly means that both of the numbers are in whole number, or both of the quantities are in whole number, or a figure. That means of same quantities. And units basically means one value is in kilometers and the other value is in liters. So this is a basic definition of rate. How do we calculate rate and how do we assume rate? Let's see the example. Shop A sells 6 eggs for $1.5, whereas shop B sells 12 eggs for 2.4. Which shop is cheap? So whenever we're calculating rate, we have to find the we have to specify the amount for each quantity. To specify the amount for each quantity. For example, in this case, there are 6 eggs for 115. What will one egg cost? So what will we do? We'll divide 1.5 among 6. We'll do the same for shop B. When we get our answer, which is 0.25 and zero point 0.2, we can clearly see that shop B is more reasonable and it's more cheap. Here, hence we use per to mean for each. This shows that we have calculated the price for per number of egg. That means one number of each number of eggs. That means one. Moving on. Okay. This is a question so that you guys, catch up to speed. Okay. A swimming pool can be filled by pipe A in 3 hours and pipe B in 6 hours. Each pump working on its own. At 9 a.m., pump A started. At what time will the swimming pool be filled if pump B is started at 10 a.m.? So you have to compare pipe A and pipe B. What we'll do, the rates of the two pipes are pump A 1 upon 3, clearly, and pump B 1 upon 6. Working together, if pump A for T hours, then pump B works for T minus 1 hour since it started 1 hour late. You can clearly see that pump A started at 9 a.m. and pump B is starting at 10 a.m. So T is the number of hours for pump A, and since it's pump B is starting 1 hour late, you write T minus 1. Hence, T into 1 upon 3 plus T minus 1 into 1 upon 6. That is equal to 1. Okay, moving on. We'll solve for T since T is the unknown variable. T is the time at which the swimming pool is to be filled by pump B. We'll solve for T. We'll get, after we separate T, we get 7 upon 3 hours, which we divided using a calculator or using simple division, we get 2.3 hours. That means 2 hours and 20 minutes. Since the swimming pool will be filled at 9, it will start filling at 9. So the time taken for the swimming pool to fill is 2 hours and 20 minutes. So the time at which both the pumps will fill the swimming pool is 12. This is 11:20. It's a very easy question to understand. No worries. Moving on. Time. Time is used to quantify, measure, or compare the duration of events or intervals between them and event sequences. We use time to calculate how a duration of when something started and when something ended. We used a 12-hour clock or a 24-hour clock, that is clear. In the 12-hour clock, midnight to noon is denoted as AM, whereas afternoon, evening, and night are denoted as PM. Noon 12 till midnight 12 is regarded as PM, and midnight 12 till noon is regarded as AM. We use 4 digits to represent a 24-hour clock. Here is just a chart to get you guys to know how the time is noted. You can clearly see at midnight AM starts and at noon it ends, and then PM starts till midnight. And you can clearly see on the 24-hour column how the numbers are donated in 4 digits. You can clearly see. Moving on. Okay, so here questions to help you people out. Okay, 1 hour gives you 60 minutes, 1 minute gives you 60 seconds, and 1 hour gives you 3600 seconds. These are just general quantities you guys need to know whenever you're attempting any question related to time. So let's go for the question. Ali reached the city hall at 1906 after working for 3.5 hours. When did he start his journey? That means he three things you have to keep in mind: the starting time, the time taken, and the time ended. So that end we are given two things. We are given the ending time, which is 1906, and we're given the duration from the start to the end, which is 3 hours and half 3.5 hours. So we'll write the data. The ending time is 1906. The time taken for Ali from home to reach the city hall is 3.5 hours. So what you'll do, there is this general formula for this. Journey starts plus the time taken is equal to time the journey ended. So we don't know the start of the journey, so we'll use a variable to represent an unknown value. Time taken is 3.5 hours and journey ended at 3:06. We'll write it in the 24-hour version as the journey ended time is. We'll subtract it simply. Since it's adding here, we'll subtract it on the other side. And when I subtract on the other side, when we minus, we get 1536. That means Ali started his journey at 1536. Moving on. Speed. This is the easiest among the three of the earlier topics we studied. Let's focus on this. The rate at which something moves is done or acts physics, a scalar measure of rate of moving of a body expressed either as a distance traveled divided by time taken or the rate of change of position with respect to a particular point. This is a general definition. To get you guys up to speed, let me just correct you with the formula and the definition. Speed is the distance traveled in a particular time. For example, Ali started his journey, journey at point A and reached at point B. The distance between point A and B will be divided by the time Ali took to travel from A and B, which will give you the speed at which he traveled from A and B. Moving on. Okay, these are general conversion units that you should be knowing. Whenever we are converting a higher number to a lower number, the higher unit to a lower unit, for example, kilometer per hour into meter per second, you'll multiply by 1,000. Why by 1,000? Because 1 kilometer has 1 kilometer is equal to 1,000 meters, so you'll multiply by 1,000. And 1 hour per hour, that's 1 hour. 1 hour gives you how many seconds? 3,600 seconds. So we'll divide by 3,600. You can clearly see the maths done over here. Moving on. When we are to convert meter per second into a greater unit, that is kilometer per hour, what you'll do is you'll basically do what? You'll divide 36, you'll you'll reciprocal the values you used in part A. You'll do what? You'll multiply by 3600 and divide by 1000. Clearly see it being done over here. Moving on. Just to help you guys with how I did the conversion thing, whenever you're going for a higher unit from a lower unit to a lower unit, you'll basically just divide or multiply as it is. Whenever you're going from a lower unit to a higher unit, the units reverse. For example, if it's kilometer per hour, it will be hours per kilometer. You'll change the values. Moving on. Okay, speed. A cyclist covers a distance of 15 miles in 2 hours. Calculate his speed. Easy. We know the distance traveled. We'll divide it by 2 hours. We'll get 7.5 miles per hour. Simple. Second, when a gun shoots a distance of 38 kilometers with an average speed of 76 kilometers per hour, and the second round is fired at 65 kilometers at an average speed of 130 kilometers per hour. Find the average speed at which. So what we'll do, a bit confusing, is both two speeds are mentioned here. Okay, to find the average speed, you'll write the total distance. We can find the total distance easy, but we don't know the time. What you'll do is you'll use the first distance and the first speed to calculate the time. How to calculate the time? Whenever you need to calculate the time, you'll divide the distance with the speed. You get 0.5, and when you do the second one, you get the same answer. When we add both of them to grant us the total time, we get 1 hour. Since the average speed formula is total distance upon total time, we add both distances and we add both time, we get the final answer, which is the average speed. You can clearly see. Moving on. Rate of revolution. Rate of revolution is revolutions are distance traveled in a circular path is donated by 3.142. You all, I hope you all know what pi is. Circumference formula, we have already discussed when we were doing geometry. 2 pi r. Okay, let's do a question. The diameter of a wheel of a car is 1.5 meters. If the car travels at an average speed of 14 meters per second, find the number of revolutions made by the wheel per minute. Okay. Solution is, first we'll calculate the radius, then the circumference. Circumference has a formula 2 pi r. 2 is constant, pi is constant, and we found out the radius in the first one, so we get 0.75. We multiply them all, we get the circumference of the wheel, that is 4.71. The distance traveled in 1 hour. Since the speed mentioned in the previous slide is in seconds, we'll convert it into minutes. 1 minute has 60 seconds, so we multiply the speed by 60. It will give you 840 minutes. Since we're multiplying the speed with the time, we are basically calculating the distance. To calculate the revolutions, we'll divide the distance traveled by the circumference of the circle. We'll get your answer. This is a very general question, very general, has a very general and unique way of doing it. Please practice this as it is. Moving on. That would be it for my explanation of this chapter. This is an easy one. I expect my students to practice more from the book, if not the book. The internet is a vast field for you guys to find loads of questions. For example, you can look up questions at Khan Academy. You can look up question at Maths to Maths Academy. You can look up question at K5 Learning. So See you guys soon. I hope you had a good time. Thank you.